Who can tell me what the word decompose means? Break down. Okay. So break it down, not like break dancing, but break it down into smaller parts, right? Okay, so what we're going to do today is decompose some fractions. We're going to take a fraction and break it down into its smaller parts that led to the bigger fraction. Okay, but before we get there, we're going to do a few examples where we just add fractions. So we're using that least common multiple concept again to get least common denominators. And then we'll work backwards. We'll take a fraction that's already been added, and we're going to figure out what two fractions added to give us that. Okay, so we're going to do in reverse what we're about to do first. Okay, so if I were going to add these two fractions, 2 over x plus 1 over 3, I would have to have common denominators. Well, a common denominator is nothing more than what we used yesterday, a least common multiple. So look at your denominators. What would the denominator need to be in this problem? 3x. Okay, notice these are not equations. So I can't multiply both sides by something over 1 because I don't have an equation where I can, say, oh, it's still equal because I applied this rule that I just did to everything. So what I have to do here is use that least common multiple, but multiply by what's missing top and bottom. So for example, here's an x. I need a 3x. What's missing? 3. I have to multiply by 3 over 3. So a slightly different twist on what we did yesterday. Ooh, some people don't like that. Because what is 3 over 3? 1. If I multiply anything by 1, do I change its value? No. Okay, so that's the difference here. It's not an equation, so I can't say, I'm going to multiply everything by 3. I can get common denominators, but I have to accomplish that by multiplying by some form of 1. Okay, here it has a denominator of 3. I need an x. So top and bottom get multiplied by x. So that again, I'm multiplying by 1. I'm not changing the value of that fraction, but it will change the way it looks. Okay, so this becomes 6 over 3x. 1x, or just x, over 3x. So at this stage, I should have common denominators. If I don't, I did something wrong. Now I can look and see any like terms in the numerators. 6 and x, those are not like terms. I'm not multiplying them, so I don't get 6x. I'm just adding. So I'm going to put that x first, just because kind of a descending order sort of thing, over 3x. Okay, then I can cancel the x's, right? Why can I not cancel those x's? It's so tempting, isn't it? It's like, we could get rid of them, and then we just have 6 over 3, and the whole thing equals 2. Why do those x's not cancel? Because I know you're going to be tempted to do that. Anybody explain it? Even if it's not perfect terminology, can you lead us on a discussion here why those x's don't cancel? Okay, 1 is multiplied by 3 and 1 isn't. All right, I'm going to give you an argument to that. What if I had this? Would those cancel? Yes. Okay, so good thinking, but that's not really it, yes? Yes. Okay, so before you start slashing and canceling things, ask yourself, if I cancel this x, is it a common factor? What are factors? Things that are multiplied. Okay, factors are things that are multiplied. So look at that numerator. Oops. Can I factor anything out of that other than 1? No. If you can't factor anything out and you don't have an x plus 6 down here, then you have no common factors. Now, if this 6 had an x squared with it, then I could take an x out of everything. But be very careful before you start canceling and ask yourself, is this a factor? Is it multiplying the whole numerator and denominator? Yes, ma'am. Split it into 2 fractions?
Yeah, that. It could be like x plus 2 over x.
because, okay, so I'm glad you brought that up. So Emily's saying, okay, well, there's a 3 there, so can't I reduce the 3's? And the answer again is no, because can I factor 3 out of the numerator? Is 3 a factor of everything up top? No. But what I can do, and usually we just leave the answer like this, but it is equivalent to splitting it apart into 2. So this is the same as x over 3x plus 6 over 3x. But what happens here? That becomes 1/3, and that becomes 2 over x. And look, that's what I started with. So I'd be like, a hamster on a wheel. I'm just going in circles. So remember, what we wanted to do was combine them. So once we get them combined, then we consider that to be like what we were looking for. We're done. Because if I split them back up, then I go right back to where I started. Okay? Any other questions on that one? Okay, look at the next one. Least common multiple is what? I'm sorry. There you go. I was like, where's he getting x minus 1? I scrolled the paper up too high. What do we need? X minus 2? Is that all? X squared minus 2x. I need both of those factors. Just like yesterday, if x won't divide evenly into this, then I've got to use this denominator also. So it's my least common multiple. I'm going to call it my least common denominator now. So I need to have, I'm going to put a little note out here. Least common denominator needs to be x times x minus 2. And in the end, I might distribute that, but now I want to think of it as just those two factors. Because that's going to help me figure out what I need to multiply each by. This one has the x, but it doesn't have an x minus 2. So I'm going to multiply top and bottom by x minus 2. I am multiplying by 1 there. It's a crazy fancy form of 1, but it is still 1, so I'm not changing the value of that fraction. Okay, over here I have an x minus 2. I'm missing the x. Top and bottom have to get multiplied by x, so that I'm multiplying by 1, not changing the value of the fraction. If it was an equation like yesterday, then I would just put both of these over 1 and multiply everything, and those fractions would cancel. It's not going to happen on these. Still going to end up with fractions usually, unless something cancels in the end. Okay, I'm multiplying here, and I get 2x minus 4. And I have x times x minus 2. Again, I might multiply those out in the end, but for now I'm going to leave them as factors. 1 times x over x times x minus 2. So I got common denominators. Now I'm going to combine numerators. So I have 2x minus 4 minus x. What does that give me? X minus 4 over x times x minus 2. And this is why I like to wait until the end to distribute. What if this ended up being x minus 2? Then it would cancel with that whole factor. But it doesn't, so you can leave it like that. I personally, Ms. Clark, do you care if they leave it or distribute? Yeah, I don't care either way. So, if that feels unfinished to you, some people just like to distribute it. Either way is fine. Yes?
I was just going to say, if you all ever get to calc, your professors are probably going to prefer the one on the left.
This one?
Yeah.
Okay. Any other questions, comments? All right, now let's jump to 3. What were you going to tell me the denominator needs to be? Just x minus 1? Times x minus 3? Both? Yes. Okay, so both factors are needed for my least common denominator. This one has the x minus 1. I've got to bring that down. I need more space. First one I have to multiply by x minus 3, top and bottom. Minus 2 over x minus 3. Okay, it's got the x minus 3 in the denominator. It's missing the x minus 1. So I've got to multiply top and bottom so that I'm multiplying by 1 and not changing the value of the fraction. Okay, we're going to multiply those two together. So that's just x minus 3 up top. And x minus 3, x minus 1. Okay, do I want to cancel these? Look, I have a common factor. Do I want to cancel? Not yet. Remember, it's like the hamster on the wheel. I'd be going right back to what I started with, not accomplishing what I set out to accomplish, which is to combine these two into one fraction. Okay, be careful here. I am multiplying a negative 2 times both of these. What do I get? Actually, I left the minus here, so I'll keep the minus there for now, and let's just do this. I forgot I already wrote that. 2x minus 2 up top. Here we go. Okay, now next step I'll do the subtracting. So those I multiplied to get that. Okay, so now this step I'm going to combine like terms in the numerator. I am distributing that negative to both of those. So what is x minus 2x? Negative x. What is negative 3 minus negative 2? That becomes plus 2. Negative 1. Okay, question. Does this cancel with that? Is negative x minus 1 the same as x minus 1? No. God, that looks so close, doesn't it? But they don't cancel. So at this point, I would either leave my answer like that or distribute the denominator. Leave it either way. Question? Good. Easier than yesterday? Yeah, mixed reviews. Alright, so suppose you have a rational expression and you want to know what fractions were added or subtracted to obtain that expression. Because I know y'all were wondering that. And if you weren't yet, then you would be lying in bed tonight going, but what if I had a fraction and I wanted to know what was added to get it? Right? So I'm saving you that worry tonight. We're going to figure it out right now. We're going to find the fractions by a process that's called decomposing the fraction into partial fractions. Sometimes we'll just say we're decomposing, or sometimes we'll say we're finding partial fractions. Same process. Sometimes this skill is needed in calculus and higher mathematics, and I'll just leave that explanation right there. Okay, so we're going to decompose this fraction into partial fractions. So, two fractions were added, maybe subtracted, and I ended up with this fraction. So I need to figure out where it began. So what do you think I need to do with that denominator? Factor it. So let's factor the denominator. You find factors for me. Minus 5 minus 3. Do we agree? That was pretty easy. Anytime that lead coefficient is 1, it's just easier, isn't it? Making a lead coefficient not 1, that's when it gets a little sticky. Alright, so that's the first step in breaking these fractions down, is to break down the denominator. Okay, so imagine that I had not this fraction, but 2 over my factors. Makes sense, right? All I did was replace the denominator with the factored form. Okay, well, I had 2 fractions that added together to give me that. I know that the 2 denominators are going to be these 2 factors, right? Like, that's what happened back here. I had an x and a 3. I needed both in the denominator. I had an x and an x minus 2. I needed both in the denominator. I had x minus 1, x minus 3. I needed both in the denominator. So if I found the factors of the denominator, I know that one of them had that and one of them had that factor as their denominators. That's how we ended up with this. Does that make sense? Okay, now what I don't know is the numerators. I don't know what this was. I don't know what this is. So I'm just going to call it A and B. Some mystery quantity that we're going to find. Okay? Now look, this is like a problem we did yesterday. It's an equation, and I can find the least common multiple of all the denominators and get rid of the fractions. So look at your denominators. What is the least common multiple? X minus 3, x minus 5. Like, it's going to be these two factors, because these two factors are also over here. So my least common multiple is here. Okay, so next step, multiply both sides of the equation by both factors to essentially get rid of all fractions. And again, I can do that because it's an equation, not an expression like we had on the previous page. Okay, so I'm going to take this whole equation here and do exactly what we did yesterday with it. Y'all are being awfully quiet. Does anybody have a question? Is anybody wondering why something happened? Okay. All right, so we're going to do the distributing here just like yesterday. What happens when this quantity multiplies this fraction? What's going to cancel? X minus 3 and x minus 5. What's left? Just 2. Is everybody okay doing that in our head? All right, let's see if we can keep it going. I'm going to ignore that and ignore that. So that those pink factors over here are multiplying this fraction. What would cancel? X minus 3. What's left? Times A. X minus 5. Oops. Times A. You can put the A in front if you want. I don't know why I put it in the back. Okay, when this pink stuff out front multiplies that last fraction over there, what cancels? X minus 5 cancels, but what's left? X minus 3. Okay, so that's a simple equation, but I've got 3 variables in it. I have an A and a B and an X. Okay, so this is what we do next. I'm going to let X equal 5 and substitute 5 in for all X's. Why do you think I said 5? Because 5 minus 5 will be 0. Okay, so that wasn't a random number I just drew out of the sky. I chose a number that would make this factor 0. Okay, so for everything, any place there's an X, we're going to let X equal 5. So this equation becomes 2 equals 5 minus 5 times A plus 5 minus 3 times B. And isn't this cool what happens? Like, that whole thing's going to drop out. That's 0A, so that's just gone. And that, I agree, it's pretty lit. 5 minus 3 is 2. So 2 is 2B. And what is B? 1. We're halfway there. Well, more than half, but we found one variable. Okay, now, I'll hold that question for a second. Okay, so next I'm going to let X equal 3. Why am I choosing 3? Yeah, it's going to drop this other factor out of the equation and enable me to find A. Okay, so let X equal 3. 2 equals 3 minus 5 times A plus 3 minus 3 times B. Well, that's 0 times B, so that's just 0. And I get 2 equals negative 2 times A. And what is A? Negative 1. Okay, so I have a question for you. What if you set this up and you put X minus 5 here under A and X minus 3 under B? Would we get different answers?
No.
We would not. Your A would be my B and your B would be my A. So we should end up with the same answer either way. And the fact that this was a negative, I could turn that into a subtraction problem if I wanted to. Instead of saying plus negative 1 over something, I could say minus 1 over something. So if it's a subtraction problem, it all works out in the end too. So it's kind of like foolproof. We're going to figure it out either way we set it up. Okay, so let's write our final answer. And our final answer is this. 2 over what I started with is equal to, now you have to make sure that you match up your A with whatever denominator you established up here. So my A goes over x minus 3. You might have set it up differently when you do your own. So I would have negative 1 over x minus 3 plus my B was 1, so I have 1 over x minus 5. Question. So look at the numerators. They don't always work out the way you would think. Like you're like, wait, negative 1 plus 1 is 0. But remember, we don't have like denominators here yet. So if we got common denominators, did the math, simplified, then we should end up with the 2 over here. The numerators sometimes will surprise you. Question? Okay, not too bad. All right, let's do another one. Oh, sorry, I didn't realize I had that. Okay, we can skip it or you can rewrite it if you want to. And I would just set it up as subtraction here. Forgot I typed that over there. Example 5. Find the partial fractions for this one. Okay, look back. What was our first step? Factor the denominator. All right, here we go. 2x squared plus 5x minus 3. Find the factors. Don't say them yet. Let everybody kind of process it for a second. Be honest, how many of you can glance at that and know what time it is? Maybe half. And that is an easier one because it's at 15. If you're not good at it, practice it. Practice. All right, what are my factors? X plus 3 and 2x. All right, do y'all agree? Okay, you might have your 2x minus 1 first and then your x plus 3. I agree as well. Okay, so then I'm going to take those two factors and rewrite this fraction as x plus 17 over the two factors. And I'm going to say that has to equal something, some mystery quantity over x plus 3 plus some mystery quantity over 2x minus 1. Because those are the two factors that lead to that denominator. Good so far? What do I do next? Yeah, I'm going to multiply by the least common multiple to get rid of all fractions. So what I'm multiplying by are those two factors. Okay, I'm going to do the little mental canceling and multiplying here. If you need to multiply that out by every fraction, it's all cool. Write it out, okay? Don't miss it because you didn't want to write it out. All right, ignore those two. We're going to distribute this quantity over here. What cancels? Yeah, both of them, right? The x plus 3's and the 2x minus 1's. What is left over? Hello. Thank you. All right. Ignore the first and the last. I'm going to distribute the pink factors to that middle fraction. What cancels? What's left? 2x minus 1 times a. Okay, ignore the first two. Distribute. 2x minus 1 cancels. X plus 3 is left times the b. What am I going to let x equal? Pull some number out of the sky. What are we going to use?
4.
Not 4.
2.
Negative 3 I like.
1/2.
1/2. How'd you get 1/2?
2 times 1/2 is 1.
You set that equal to 0 and solve it. Okay, so if it's something complex and you can't quite figure out what you need to use, come over here to the side. I need to use x equals 1/2. Now that one's easy. That's negative 3, right? Okay, so let's do the hard one first. Let's do x equals 1/2. Okay, so wherever there's an x, 1/2 goes in the place. 1/2 plus 17. Not always nice numbers. 2 times 1/2 minus 1. Plus b times 1/2 plus 3. You may want to grab a calculator on this one. If those decimals are scaring you. What is 2 times 1/2? And what is 1 minus 1? 0. If one of these isn't 0, then we made a mistake. So that is just 0. A times 0 is 0. So I have 17.5 equals 3.5b. Divide, and what does b equal? Anybody? 5? Even? No, 5 is right. All right, next we'll go with the easy one. I'm going to let x equal, what do we say?
3.
Negative 3. Okay, negative 3 plus 17, a, 2, negative 3, minus 1. Okay, all x's get replaced with negative 3. Good? Okay, simplify. Negative 3 plus 17 is 14. 2 times negative 3 is negative 6 minus 1 is negative 7a. And this is 0. B times 0 is 0. So if 14 equals negative 7a, what is a? Negative 2. Okay, and I'm going to go back above this problem because I did not give myself enough room where I wrote too large, and I'm going to write this fraction again. Okay, so I'm going to have x plus 17 over 2x squared plus 5x minus 3 is equal to, now the way we set it up, we put a over x plus 3. A is negative 2. So I have negative 2 over x plus 3. Make sure you pair it up with the right fraction. Plus, b was over 2x minus 1. b is 5. So 5 over 2x minus 1, that represents my partial fractions. Ooh, just enough time to do one more. Who said no?
Me.
John, huh? Yes. Wait, do I need to slide it up to there or further down? Okay. Yes.
Now integrated.
Not yet.
Do they do that?
No, that's a BC topic.
Because I remember this is what we did, but she never taught us it like this.
Oh, really?
It was so much more complicated.
Well, you probably did harder fractions too.
It was. I just remember like most of the time it was like very like it was like x cubed over x squared, so it was always less on the bottom.
Yeah, yeah.
And then you have to separate it. That she never taught us that. Like she never told us that. I never could figure that out. But
Oh.
it was apparently a lot more easy. And then
Okay.
after that, you just do it.
Okay. All right. Do you guys want to try this one on your own?
Yeah. Yes, you do.
Okay. I'll tell you what. Shh. I'm gonna work it out up here, but I'm not gonna talk through it. You don't have to listen to me. So if you need to watch or peek, then do so. But if you want to talk to your neighbor about it, try to figure it out on your own. That would be great too. Go back and look at the steps that we used. You're not going to talk about it? Is that what you said?
No.
I'm going to get me a fly swatter. Try to do as much on your own as you can. Okay, if you are having trouble or have a question as I walk around, let me know. You not bring the homework as